What is up, YouTube? Mr. Keen coming at you live from the studio. Here are the bellwether questions for the day. Please answer the questions now. Pause the video. Okay, moving on. I just want to review the equation with some cahoots. So remember, here's a formula to determine how much energy something has. Q is equal to mass times specific heat times delta T. Okay, remember yesterday we went over Q is known for having energy in joules. M is for mass. C is for how much energy you need to change the temperature by 1 degree. It depends on the material. And then delta T is all about changing your temperature. Okay, here's some announcements. And since you're watching the video, you missed the Kahoot, but when you're ready, I'm going to go over the calorimetry practice problems answers. So you can pull up the assignment from Tuesday. We're going to go over these questions. Okay, number 1, how much energy is needed to change the temperature of 50 grams of water by 15 degrees? So figure out what you already know, and then you should have determined that you need to find Q. Since we're just finding Q, you already know the equation you should use. Q equals MCAT, and then plug 50 in for M, 4.18 for C, and 15 for delta T. And you should have gotten 3,135 joules. Next, 2 was a little harder. 2, you did have to do some subtraction. You take the final temperature of the water minus the initial temperature of the water. So you should have ended up getting a negative number. So 12.7 minus 25, you get negative 12.3 degrees. Note, there's no such thing as negative energy or negative temperature. The negative just means you're losing temperature because it's getting colder. Okay, but now you know what M is, what C is, and what delta T is. So now you can find Q. And then it's the normal equation. And then once you plug in all the answers, you'll get negative 1,542.42 joules. The negative just means you're losing energy because it's getting colder. All right, number 3. This one might be a little tricky. The specific heat of aluminum is 0.9 joules per gram per degree. How much energy is needed to raise the temperature of a 20-gram block of aluminum from 22.8 degrees to 94.6? What letters do you already know? So for this, just figure out what you know. If it has a number attached to it, then you know it. So it starts out giving me the specific heat of aluminum, so I know C. And it gave me 20 grams, so I know M. And it gave me some temperatures, so I do know delta T. That leaves, if I know C, M, and delta T, I still need to know Q. Since I just need to know Q, I go to part C. That's just the normal equation. Q equals M times C times delta T. Okay, once you plug in all the info, just Google calculator. So we're going to take delta T, will require an extra calculation. To find out delta T, do 94.6 minus 22.8. You should get 71.8 degrees. And then we know M is 20 and C is 0.9. So you're going to multiply 20 grams times 0.9. And you can take the initial temp and the final temp. So 94.6 minus 22.8. And then your final answer should be 1292.4 joules. Cool. So that's number 3. Number 4 is the trickiest. Now it's a little different. It's asking what is the specific heat of copper if I took 57.8 joules of heat energy, added to 10 grams to produce a 15-degree temperature change. What letters in Q equals MCAT do I already know? So if it has a number attached to it, I know it. So it says 57.8 joules. So I do know Q this time. And then it said 10 grams, so I know M, and it gave me the temperature change. so no delta T. Since I know these three things, I do know C. Now, I have to manipulate the equation. So the original equation is M times C times delta T. But I need to find C now, not Q. So I need to get C all by itself. And to do that, I need to do algebra. So since the M and the delta T are attached to the C by multiplication, I need to do the opposite to get C by itself. So what I'm going to do, I'm going to divide both sides by M times delta T. And what that will give me is Q divided by M times delta T equal to C. Because I divided M and delta T by itself, they'll cancel out. So I'm left with C is equal to Q divided by M times delta T. And that's going to be my answer for part C. That's the equation I'm going to use. C is equal to Q divided by, make sure you have in parentheses, M times delta T. Now I have the formula. I have all the information I need. I'm just going to plug it all in. So I'm going to start with 57.8 divided by, in parentheses, mass times delta T. So 10 times 15. And then my answer, you can round it to 0.39. That's how much the specific heat of copper is. Last one. This one, I took the training wheels off. No follow-up questions. You just had to put all the work here. And the final answer. This question, how much energy in joules do I need to heat 100 grams of water from 35 degrees Celsius to 100 degrees Celsius? Okay. Specific heat of water is 4.18. So first thing, just got to figure out what I know. So I gave you 100 grams, so I do know M. I know M is equal to 100 grams. I did give you delta T, because I gave you the degrees, and I gave you C. So C is equal to 4.18. And for delta T, you do need to do some math. So you take the final temp, 100, boiling, minus 35. So 100 minus 35. That's equal to 65. So now I have delta T, and I have C, and I have M. So that leaves me with Q. So now I'm going to plug them all in my calculator. So 100 grams times the C of water, 4.18, times 65 degrees. That is the final answer, 27,170 joules. That's why it takes so long to cook that pasta, because you need to put a ton of energy into that water. Yep, that's the last thing. After you got all the answers, please go to Friday and do this attendance survey. It is a practice quiz, so you won't necessarily get 100% unless you try really hard and do your best. Thank you so much, everyone, for watching me the whole time. Have a great day. Bye.